Hello and Assalamualaikum. My name is Muhamad Afnan. Now I will present my slide about flex fibers composite, effect of fiber orientations and mechanical properties via Ansys simulations. Here are some of the detail about presentation outline. This slide is about flex fibers, or in scientific name is Lineum ucitasimum, and this flex fibers is categorized as a natural fibers. As we know, the advantage of natural fibers is environmentally friendly, safe from human skins, and biodegradable and have a good mechanical properties. Okay, this fiber is took from bust of flax plant. Flax fibers are also known as technical fibers, consist of a number of ultimate or single cell fibers that are built together. The flax fibers create high interest for many applications due to its excellent properties and low densities. Flax is the one of the strongest fibers considered from available plant fibers. These are three objectives that we do in this research. First objective is to evaluate the effect of fibers orientations on tensile, compressions, bending, consistency indentations, strength, and the formation of flex epoxy composite. Second, to determine the effect of layup sequence for flex epoxy composite. Third, to study the effect of fibers volume fractions of FRP composite. In this table, it shows the scope that I have done in FIP2, which is to do the modeling for tensile, compressions, flexural, KSI by following the standards. There are two layer sequence that I have done in this FIP, which is theta plus theta and theta plus theta with 0 degree. For the types of fibers that I use is flex epoxy and glass epoxy with volume fraction is 60% and 30%. Here are the flow of methodologies that we use in Ansys simulation. The first simulation step is by create elements, where at here we create the specimens, and the second step is put the material properties and failure criteria. The third step is make a sectionings, where fiber supply orientations we start from 0 until 90 degrees, and the layer sequence is plus minus theta and plus minus theta with 0 degree, where S is present as a symmetric ply. The fourth step is meshing. For this Ansys, we use 8x8 mesh, but for open hole is use 1 mm mesh because when we do a convergence analysis, show that this is the best mesh for this specimen. Final step is define boundary conditions and define the load, where in this figure show that for every test have a difference of boundary conditions and load. This is the mechanical properties that I use for this analysis. For glass epoxy, volume fraction is 60 and 30%, and also flex epoxy. This is the result for tensile unhold. As we see at this result, show that the maximum stress is decreasing when the degree of orientation is increasing. This is because under the tensile load, parallel to the 0 degrees fibers orientation had a highest tensile strength. Because the specimen failed due to the tensile ruptures of the reinforcement fibers and rebonding of the fiber matrix interface. Meanwhile, the specimen have the lowest tensile strength under the transverse tensile load at 90 degrees fibers orientations. as they are filled to the two tensile ruptures of the fibrous metric interface. However, when we compare with theta minus theta layup sequence composite with theta minus theta with 0 degrees layup sequence have the highest maximum tensile strength. This clearly demonstrates how the layup sequence 0 degree fibers ply orientation affect the composite tensile stress. From graph A and B show that glass epoxy volume fraction 60% and 30%, the maximum tensile stress for volume fraction 60% is highest than 30% volume fractions. This is because the volume fraction of fibers for glass epoxy 60% is highest. Therefore, the largest fibrous volume fractions usually means the composite mechanical properties are better. Next is the effect of hole for tensile. From this table show that the maximum open hole tensile with the stress for glass epoxy and flax epoxy composite for layup sequence. In figure A show the maximum tensile stress generally decrease as the angle of fibers rotation increase, and when the hole size is increased, the maximum stress will decrease. This is because the presence of a hole is in the specimen act as a stress riser, causing the fibers along the hole edge to fill. This figure shows the example of maximum deformation contour for hole and unhole flax epoxy that have done in Ansys software. The composite maximum deformations is also influenced by the layup sequence. Aside from that, the maximum deformation impact is also influenced by the composite maximum stress. If the maximum composite stress is highest, the maximum deformation is also highest. This table shows the maximum compressions for unhole stress for glass epoxy and flax epoxy composite with various layup sequence. For this compression also show that the result maximum compression stress generally decrease as the angle of fibers orientation increase. However, when we compare theta minus theta layup sequence and composite with theta minus theta layup sequence with 0 degree layup sequence had highest maximum compression stress. This clearly demonstrates how the layup sequence 0 degrees fibers ply orientation affect the composite compression stress. When compare graph A and B show that glass epoxy volume friction with 60% and 30%, the maximum compression stress for glass epoxy volume fraction 60% is highest than volume fraction 30%. This is because the volume of fibers for glass epoxy is 60% is highest. Therefore, the largest fibers volume fractions usually means the composite mechanical properties are better. Next is the effect of hole for compressions. For this table show the maximum open hole compressions with stress for glass epoxy and flax epoxy composite for plus minus theta layup sequence. For unhole structures, the structures for fibers reinforcement epoxy composite material show a highest maximum stress volume than the open hole. This is because the lowest maximum stress for fibers reinforcement epoxy composite material due to the hole in the specimen act as a stress riser, causing the fibers along the whole edge to fail. This table shows the example of maximum deformation contour for hole and unhole flax epoxy that have done in Ansys software. This table shows the maximum deformation impact is also influenced by the composite maximum stress. If the maximum composite stress is highest, the maximum deformation is also highest. Next is flexural. From this table, show the maximum flexural stress for both glass epoxy and flax epoxy with the different type of the fibers ply rotations. This maximum flexural stress decrease from 0 to 90 fibers ply rotation according the result. It demonstrate that composite with a 0 degree fibers ply rotations may sustain highest loads than composite with others fibers ply rotations. When we see in figure A and B, show that the effect of 0 degree fibers ply rotation affect the composite's flexural stress. However, when compare glass epoxy volume fraction with 60% and 30%, show that the maximum flexural stress for glass epoxy 60% is highest than glass epoxy 30%. Therefore, as a largest fibers volume fractions usually means the composite material mechanical properties is better. Under flexural load, this figure show the example of maximum deformation flax epoxy composite. This table show the effect of fiber ply orientations on maximum deformation of glass epoxy volume fraction with 60% and 30% and flax epoxy. For glass epoxy, both specimen with and without supporting ply angle 0 degree, the volume of the maximum deflection increase as the fiber orientation increase until fibers orientation 45 degrees before the begin to decrease until fibers orientation 90 degrees. For both specimen with and without supporting ply angle 0 degrees, the value of maximum deflections decrease as the fibers orientations rising from 0 to 90 degree for glass epoxy with volume friction is 30%. For flax epoxy, the volume of maximum deflections decrease as the fiber rotation increase from 0 to 90 degree for both specimen with and without supporting ply angle 0 degrees. Next is QSI. From this table, glass epoxy with a volume fraction of 60% possess a greater QSI strength at 45 degree, followed by glass epoxy and glass epoxy with a volume fraction of 30%. Overall, the highest maximum QSI stress can be seen from 45 degree fibers orientations, while the lowest maximum QSI stress is seen from a 0 and 90 degree fibers orientations. And when we compare the glass epoxy with volume fractions 60% and 30%, that show that volume fractions with 60% is greater maximum QSI stress compare glass epoxy with a volume fraction 30%. Therefore, the increase in fibers volume fractions affect the maximum strength. From this result, show that glass epoxy volume fraction with 30% is the lowest QSI strength than flax epoxy. At table A, show that the glass epoxy composite with volume fraction 30% have a greatest maximum penetration depth to glass epoxy composite with 60%. This because the fibers volume fractions affect the deformability of the composite. That show when the fibers volume fractions increase, the composite becomes stiffer and will decrease the deformability of the composite. However, flax epoxy have the greatest maximum penetration depth to glass epoxy composite. This show that the flax epoxy have a better deformability and better fibers metric interface than glass epoxy. From table B, it shows that the effect of fibers reinforcement on penetration depth before failure load. And these three results show the comparisons and comparison on penetration depths obtained from different composite specimens with layup sequence of 45, negative 45 with a load of 500 Newton per meter. Where glass epoxy 60% is penetration depth is 0.0652 millimeters. Glass epoxy with volume fraction 30% is 0.395 millimeters and flax epoxy is 0.178 millimeters. Next is the conclusion for this FIP is the fibers volume fraction is another factors that determine the composite maximum stress. The composite with the plus minus theta with 0 degree layup sequence has a greater maximum stress than the composite with theta minus theta layup sequence. The addition of 0 degree fibers rotations to the composite supply stacking sequence increase the maximum strength. That's all from me. Thank you.